faculty development program organized by Department of Mechanical Engineering along with the Gujarat Council of Science and Technology, a joint venture of Department of Science and Technology. So first of all, I would like to welcome today's speaker, Dr. Brajesh Kumar Dubey. I would like to introduce him. Dr. Brajesh Kumar Dubey, he has done his BTech from IIT Kharagpur in 1997 with the gold medal in civil engineering. He did his PhD in 2005 in the environmental engineering and science from the University of Florida, USA. If you see the experience of him, he is working with IIT Kharagpur from 2015 onwards. Currently, he is holding the position of Associate Professor in Civil Engineering Department with the specialization of Environmental Engineering. His total experience, if we see, then he is having a more than 20 years of total experience. Out of that industry experience, he is having more than 5 years. If we see his awards, then in 2018, Endeavour Executive Fellowship from Department of Education and Training, Australian government has awarded this fellowship to him. In 2008, Certificate of Academic Excellence from Hinckley Center for Solid and Hazardous Waste Management from the Gainesville, Florida, USA. In 2005, Outstanding International Student Award from College of Engineering, University of Florida, USA. In 2004, Ron Cockcroft Award from International Research Group on Wood Protection. In 2004, he got from the Sweden this award. He has published many publications. He has published patents also, certain original research and review articles in internationally reputed journals also he has published. If you see the numbers, that number is very large. More than 195 papers he has published. Out of that, 62 papers are in referred journal articles, 26 is in conference or proceedings, 65 abstracts, magazine articles 5, technical review projects reports 22, other project reports 8, and book chapters, if you see, then he has published 6 book chapters. So very rich profile person we have for delivering the lecture related to the advanced waste management system. I request Professor Brajesh Kumar Dubey to start his speech. Thank you, sir.
Thank you. Thank you very much for the introduction. So I will get started. So let me share my slide. So can you see that okay?
Yes, sir. Yeah.
Okay. So again, good morning. You are most of you probably in Anand or Gujarat area. Like I whenever I used to cross Anand by train, as mentioned, I have industry experience. So out of 5 years of industry experience, actually 4 years I was working for EIL, Engineers India Limited, and we have offices in Baroda. We have offices in Jamnagar. At that time, we used to have offices in Jamnagar and several other places, Mehsana. So I used to travel, and my elder brother used to live in Mumbai. So I was in Jamnagar for a while too. So I used to travel between Ahmedabad and Bombay by train, and then I would take a bus from Ahmedabad to Jamnagar. So in between Ahmedabad and Bombay, I would get down in Anand and have that milk. So whenever we think of I think of Anand, I think of Amul. That's kind of very very famous, and enjoying all that flavored milk that you have at the railway station and different places. So let's get started. So we will be, since we talk, as I said, milk. milk pouches are also coming in plastic, isn't it? So we are talking about plastic waste management this morning for next hour, an hour and 15 minutes. I'll try to finish my talk by around 11:10, so that we have around 15-20 minutes of question and answer session. You can put your questions on the chat box, on the Google chat box, as you may be aware. And so we can take the questions towards the end. Unless you have something very burning, then you can ask in between as well. So today's topic is on plastic waste management. We'll talk about global issues as well as the Indian issues associated with that. Now, if you look at plastic has moved. You can find plastic everywhere. So plastic is there in Mount Everest, which is almost 8,000 meters above sea level. Plastic is also there almost at around 11,000 meters beneath the sea surface. So 11,000 meters beneath the sea surface, 8,000 meters above the sea surface. So we are looking at almost 2 kilometers stretch, like 2 kilometers stretch in which we have plastic. So, and it's in soil, it's in water, it's also in air. So plastic waste has becoming a big problem. Now I want to make one thing very clear. See, plastic as a material is not that of an issue. Other than some products like those single-use products will be talked about, that we should try to reduce the single-use product from the plastic as much as possible. But plastic as a material has really done a lot of wonderful things for us. If you look at many of the items today is made out of plastic. And those plastics and those, like, it's very difficult to make those products by some other material. So plastic is needed. We cannot really get away with plastic unless we have a material which is very similar to plastic or better than plastic, which can produce all these different products and which is also economically viable. We are in, I think audience is mostly from Gujarat. So, you know, धंधों के लिए तो धंधा अगर करना है तो इकोनॉमिक्स तो काम करना चाहिए. अगर इकोनॉमिक्स ही, अगर पूरा इकोनॉमिक्स ही काम नहीं किया धंधा में, मतलब तो कोई होगा नहीं, धंधा नहीं हो सकता. So, and you guys know that much better than me. So it has to be economically viable. Then only you can have a replacement. But what is the problem then? The problem is not plastic as a material. The problem is plastic waste. Now you may say that plastic, the main source is the plastic as a material. Yes, main source is plastic as a material. But when it becomes a waste, when it comes into the waste stream, we are not managing that waste stream properly. That is creating all these issues. That's why you see, like, for example, you saw the picture on the Mount Everest. Like this picture on Mount Everest, you see people throw it away. Like, why did they throw it away? When they took it with them, they could have brought it back down with them as well. Why it is going into the ocean? It is not supposed to go into the ocean. When the plastic was designed, it was not supposed to go into the ocean. It was supposed to be used for different packaging, and at the end of its life, it was supposed to be collected and managed properly, either in a waste to energy plant, or you go for recycling plant, or whatever you want to do it. But not throw it into the rivers and in your drain, and then to the river, and then to the ocean. So the problem is improper management of plastic waste. So that should be the focus, not plastic as a material. Plastic as a material is getting a lot of bad press, unfortunately. But plastic as a material actually has done a lot of good things for us as well. For example, if you look at your car today, car has become lighter. Now, car lighter means better fuel mileage. Better fuel mileage is helping the environment. If I can travel more kilometers with 1 liter of petrol or diesel, that is going to save the environment. That is going to help the environment. You go to any hospital, we have this COVID crisis going on right now. You go to any hospital, you will find many of those appliances, those tools and tubings and other stuff is made out of plastic. So we rely on plastic from early morning to late evening. Even the mouse that I'm using right now to have this lecture, the screen that I'm looking at the screen that you are looking at, the laptop or the desktop or your mobile phone or whatnot, everything has plastic. So you cannot really live without plastic today. So what we need to do is to better manage the plastic waste. And that's where the focus has to be. Better manage the plastic waste. And that's what we are going to talk about in next 1 hour. So here it says plastic waste has reaches into Antarctica. So it is again because of not being able to manage properly. So now, before we get into what is plastic waste and all that, so first of all, what is plastic? Plastics are actually synthetic. Plastic is your synthetic or semi-synthetic organic of very high molecular mass. It can be modeled into solid objects of numerous shapes and sizes. As you can see here, you can make lots of shapes and sizes from this plastic, and that's what makes it really interesting material. You can give lots of shapes and sizes to this material, either like a one particular resin, or it is a mixed resin. Many of these are mixed plastic. For example, this keyboard and your the remote and other stuff is mostly mixed plastic. It's not only one type of plastic, but it gives a lot of flexibility. You can give a lot of shapes and sizes, which is not possible, say, if you want to do it with metals or glass and other stuff. They are essentially hydrocarbons, and they are byproducts of petroleum. And they byproduct fractional distillation. They have a basic hydrogen structure. We'll look at that. And it also has a lot of additives like colorants, plasticizers, stabilizers, and fillers. And these material, these colorants, plasticizers, stabilizers, and fillers, they influence the property of plastic. They also have heavy metals and certain organic compounds which have negative effect on the environment. So if you look at the plastic resin, like if you pick up any plastic product, you will see these different numbers. There's a PET, HDPE, PVC, LDPE, PP, PS, and others. So PET is your polyethylene tetraphthalate, so which is easily recyclables as well. So you use the soda and water bottles, cups, jars, trays, clamshells, and you can recycle it in clothing, you can recycle it in carpet, or in clamshell, or you can put you can put new water bottle out of that. Then we have HDPE. HDPE is your high density polyethylene, which is your milk jug, detergent jugs. You go and buy, if you go to Big Bazaar or those kind of stores, you buy those Dhara oil or Saffola oil. So these are all your HDPE, high density polyethylene. Then we have PVC, LDPE, PP, and all that. So different types is out there, and each one of them has certain properties, and they have certain products which certain product type which comes out of which is used. These plastics are used to make those product type, and then you can recycle them into certain applications. So you can that is out there. Now, how these plastics are made at the first place? This is if you go to any of these, so you have several petrochemical plants in Gujarat itself. If you go to, for example, if you go to Jamnagar, and if you go to the Reliance refineries and petrochemicals, where I have lived in Jamnagar for almost 6 months, where we used to take the bus and go to the Reliance site, and there is a SR site there as well. So if you look at all these like a petrochemical plants, you will have what is known as the naphtha cracker unit. Which is first you have this crude distillation unit. What you are looking at here is a crude distillation unit. This crude distillation means separation. So it is being separated as per the temperature. 70 degrees centigrade is the low temperature, and then high temperature is your 360. So in terms of these high temperature and low temperature, so you get different products coming out of it, like gases, petrol, gasoline, naphtha, kerosene, diesel, lubricant oil, and all that. So you take this naphtha and take it to the separation unit. It is called naphtha cracker unit. So in naphtha cracker unit, you separate it into either ethylene, polypropylene, butadiene, and all those different products. So in terms of ethylene, you take this ethylene or ethene, and then so there are individually, and then they come together, as you can see in the small animation going on the right hand side of your screen. I think you can see my laser as well. You should be able to see the laser. If not, you let me know. So it gets together, and then you get, since many of these are coming together, that's why it is called polythene. Poly means more than one, many. So ethene coming together, making your polythene. That's why plastics are called polythene. So that's the, so you have this is another same process shown in terms of a 3D, kind of so in a 3D scale, from the gas wells, from the petrol, diesel, like from your crude. Then you have your processing plant, you have the fractions happening, then your liquefaction, ethane cracker, and then plastic manufacturing, different types of plastic that is made. So Once when it's mixed, like when your raw material is ready, you put it under these different blow molding, injection molding, extrusion, and then you give it different shapes and sizes, and you make all these different products coming out of that. So it's you can do vacuum forming as well, thermoforming. As you can see, depending on what shape and size you require, you can do calendering to get those thin layers of plastic, those used for packaging and all that. So this is different ways. This is just a few examples. There are several ways to do it, and you make those products. Now, why plastic? It's first of all, the question comes, why plastic? What is so like good about plastic that it is so popular? It is cheap, as you can see here. It's light and compact. It's water. It is water resistant. Thermoelectrical insulation is strong, durable, safe, and hygiene for food packaging. That's what it is being used. So as you can see, like if you go to any store these days, in Ahmedabad, there is one. There is one this is Kanti Ben's Ghagra, is it? Kanti Ben's Khakra, isn't it? That's Kanti Ben, or I'm forgetting the. It's very famous. So
Sonal Ben.
Sonal Ben, sorry. So you go there, you go to those shops, and you find any product. They're all packaged in plastic. Since we are talking about Gujarat, I'm trying to give you Gujarati flavor a little bit. Although I like that, I Kathiawadi, that Fafda, Jalebi, and Sarat Purnima अभी just गया. Sarat Purnima का वो लड्डू भी मैंने खाया है, जिसमें कि पूरा बटर ही होता है. आधा से ज्यादा आप नहीं खा सकते. बट हमारे लैंडलॉर्ड ने जबरदस्ती खिलाया था हमें जामनगर में. तो so गुजराती लोग बहुत खिलाने पिलाने में मस्त आदमी है. तो which I enjoy. Like people like me who like to eat. For me, गुजरात में और जो वेजिटेरियन है, उनके लिए गुजरात में बहुत ऑप्शंस है. पूरा फरसान और ये खाते रहने का उधर. So this is because and you look at all those packaging, and all those packaging is your is plastic. Why it is in plastic? Because when it's inside the plastic, it stays fresh for a longer period of time. Moisture अंदर नहीं घुसेगा आपका. जब rainy season is almost over. Rainy season, many things will get bad if it's just outside. You pack it in a sealed packaging using this plastic. It stays for a longer period of time. So if the plastic was not there, otherwise we would have done a lot of food waste, isn't it? So we could have done a lot of food waste if we had not had any other material to do. So it has done a lot of good for our day-to-day living, and also help the economy. The problem again, you will hear me say that again and again and again. The problem is the plastic waste, not plastic as a material. It is the waste generated on discarded plastic, which we are not managing properly in India and also in many countries around the world. So if you look at plastic, we have produced quite a bit of plastic. Humans have created 8.3 billion metric tons of plastic to date. It's outgrowing all man-made materials other than steel and cement. So if you list man-made material in then plastic is at number 3. We have steel, cement, and plastic. So that's so much of plastic we have created, and so much of plastic we have used. So if you look at try to put that in 8.3 billion tons, metric tons, that's almost 822,000 times Eiffel Tower. Eiffel Tower's weight is 1100 metric ton. It's 25,000 times Empire State Building, 80 million times the Blue Whale, or 1 billion times the like typical elephant. One elephant is 7.5 metric ton. So it's so that much amount of like a plastic that we have produced. And so 1950, it was around 2 million metric tons. 2017, it was 8.3 billion metric tons. By 2050, the market is going to go up to 34 billion metric tons. So it is there. So when you use this plastic, of course, there will be waste being produced. So as you can see, in 2015, we produced around 6.3 billion metric ton up to 2015. Up to the 2015, we produced around 6.3 billion metric tons of plastic waste. And by 2050, that number is expected to grow up to 12 billion metric ton of plastic waste that will be produced so those plastic has to be recycled, has to go for waste to energy plant, and has to do resource recovery. We cannot have this only 9% recycle. So that's the problem right there. Only 9% of the global plastic gets recycled. In India, we don't have the exact figure. India, the Central Pollution Control Board actually says that we recycle almost as close to 60%, and it is mostly done in the informal sector. Since informal sector, we don't collect those figures, we don't know for sure. But of course, India does much better than 9%, we can say that for sure. And 9% is the global average. So only 9%, and 12% is incinerated. Incinerated means since plastic is coming from oil is fossil fuel, so you can use plastic as a fuel as well and generate electricity from that. So 12 plus 9, 21% is at least some form of resource recovery. Rest 79% is mostly accumulated in your landfills, which is will create a lot of problem. So that's what we need to work on. We need to reduce this 79%. And we need to move, increase this 9% and 12%. And then we have to work on reduction of single-use plastic, which is right here. 40% of the plastic is single-use. So that's 60% is not that of a problem. That 40% of plastic, which is single-use, means you have just used it once and discarded it. So that plastic is what is creating a bigger problem. And that plastic, either we can reduce the usage of that plastic as much as possible, and we'll tell you some examples in this lecture, or you do waste to energy or some sort of resource recovery from that. You can do pyrolysis, different thermochemical treatments are out there, which you can use to do some resource recovery from this plastic waste. If you look at plastic consumption in India, Western India, where you are sitting right now, is the highest, or close to 50%. 47% of the plastic consumption is in the Western India. Gujarat, Maharashtra, those are kind of leading the pack there. Then we have Northern 23%, Southern 21%, Eastern region 9%. And that kind of reflects the way the GDP is of this. If you look at the different states, in India and look at their GDP contribution to the Indian GDP, you will find the Western states have much higher contribution, like Maharashtra, Gujarat. They have a lot of industry there. Gujarat is a highly industrialized state, very different from several other states in India, which are very much in agriculture. Agriculture does happen in Gujarat too, but it's industries is also a lot of industries there. So you can and same and also in Maharashtra or a little bit in other northern states. So you see wherever you see more industrialization and other stuff, you see more plastic being used, which kind of obvious. If you look at the top 10 plastic generators, of course, if it's more uses there, more plastic waste will also be generated. So number 1 is Maharashtra, number 2 is Gujarat, then Tamil Nadu, then we have UP, too much population. So although per capita will be less, then you multiply by the number of people, it will be much higher. Then you have Karnataka, Andhra Pradesh, Telangana, Punjab, Jharkhand, and several states data was not available as well. But again, you can see Maharashtra and Gujarat kind of leading in terms of plastic waste that is being produced. And this number is only going to go up. As you can see this projection on this particular figure, the number is only going to go up. This is, it has taken to, it came in 2018. So they had the data up to 2015-16, and then they have projected it based on how much it is being used and based on how the GDP will increase and all that. So as you can see, developing Asia where we are, so you will see an increase all the way up to like 2070, 80 or 2090. After that, there is a slightly decrease. So there will be an increase in terms of plastic demand. If the more plastic used means more plastic wasted. So that's what you're going to see that there too. So sources of plastic waste, how the plastic is getting into the environment, the plastic waste. So municipal sources, which is what you and I are producing and putting it in our trash. Distribution and industrial sources. If from industry, you will have some leakages during reject products from the industry. Distribution system, there will be other sources as well, industrial leakages, microbeads, which is used in our different products, like even of those, many of those toothpaste, which feels like sand. अगर कोई भी सामान जिसमें कि वो रुखड़ा जो होता है ना, जो like rough feeling if it's there, people use those scrub, अपना face wash, those scrub which gives the very rough feeling, which kind of takes to take your dead cells away. So that also has microbeads, and those are microplastics. Those toothpaste, which has that feeling of sand kind of feeling, that also has like a microplastics. So you have a lot of sources in the product which plastics are being used, and then those your macroplastic, big size part plastic, also are degraded and fragmented into the environment, and then you go into a smaller size, which is your microplastic, which is known as a secondary source. So this, whatever I was trying to explain in the previous slide, this again, the same thing has been presented in a pictorial way. So plastic can come from waste, plastic can come through our sewage treatment plants. When we use our dish, like a washing machine and other stuff, there also when you wash your clothes, this t-shirt that I'm wearing right now, that has a recycled plastic in here. You see all those fancy t-shirts that IPL team wears. Those has my recycled. Those also has recycled plastics in them and recycled PET for most part. And when they wash it, little bit of plastic just goes off of this and get into the environment. So, and then littering of the waste being thrown here and there. Then you get like a single-use plastics, a lot of stuff from the single-use plastic, bottles, fishing nets. In the ocean, sometimes the containers are lost. People littering things in the ocean. And when I was working in Mumbai, that time it was Bombay, now it is Mumbai. We had I used to be in Bombay High, 15 days in the sea, 15 days in the land. We have our office in the Nirmal building, EIL office in our Nariman Point, close to that Oberoi Hotel. So here, as we have used to be on the ship, we used to be on the barges in the ocean, and there in in Arabian Sea, and where we used to do some subsea welding, subsea piping, and all that. You guys are mechanical engineer. You knows all that stuff. There, in fact, I ended up learning how to read welding, how to read in the black room, how to look at the welding and say whether the welding has been done properly or not. So there, many times I used to see that most of the waste produced on those barges are just dumped into the ocean, and again, quite a bit of plastic. I'm talking about late 90s. So at that time, not plastic usage was still a bit low, but today it's much higher. So think about all those barges and other stuff which is there in the ocean throughout the world. Barges, ships, cruise ships, and all that. People dumping their waste into the ocean and creating a lot of problem. So where these plastics are ending up, every mismanaged plastic, whether it's in your and I houses from yours or mine or anywhere, ultimately it is getting into the ocean. Because see, if you don't manage plastic waste properly, it will be sitting on the side of the road. Next time it rains, it gets into the drain. From the drain, it goes to the stream. From the stream, it goes to the river. From the river, it goes to the ocean. So finally, last, like a sink, is the ocean. So that's where your waste is being. So you will have North Pacific gear, Indian Ocean gears. So you South Pacific, Great Pacific garbage patch. You see a lot of plastic garbage patches in the subtropical gears. You see all those purple patches is your plastic garbage patch. Now, what does that plastic garbage patch means? Here is the picture. As you can see on the right hand side, can you see this? The small animations going on the left. You can see that, okay? These animations here and here.
Yes.
Yes. Okay. Okay. Good. So you can see all those plastic. That is why the managing plastic waste properly is very, very important. You may think that say like how it's happening in the ocean. Why should I be worried? See, it's a big impact on in industry. The economy is getting impacted. All those shipping companies, all those recreational stuff that is getting affected. So all those are business, isn't it? If the business is not there, like where the jobs will be. So directly or indirectly, it is affecting us. Even if you don't enjoy seafood, even if you are strictly vegetarian like I am, but it's still these because people say the plastic plastic is getting into the tissues of fish. So eating fish is also becoming a problem. Although in Bengal, they consider fish to be vegetarian, isn't it? If we have some Bengali in the audience, they will say Bengal में actually fish को जॉलेर फॉल बोलते हैं, जल का फल है वो, जल में जो फल होता है वो मछली है. So Bengal में fish is a vegetarian. So, but for many of us it is not. But I'm just making a joke there, trying to keep you awake. But so as you can see that this is what is showing up, and you can find lots of YouTube videos and lots of pictures where you will see these kind of. So this is not acceptable. This is not for, and this could be waste. This kind of patches you can see in different all the oceans, and this could be waste that you and I did not manage properly. It just because of everybody is contributing to that. Entire planet is contributing to this problem. So we have, and this gets broken down and gets into smaller pieces. So anything less than 5 millimeter is called as microplastic. So less than 5 mm is your microplastic. So we have also, the research has been done where they found the ocean microplastics are coming from synthetic textile, coming from car tires, coming from city dust, road markings, marine coatings, personal care products, plastic pallets. So different sources of this is coming up. And Great Pacific Garbage Patch, for which you saw the picture on the previous slide, it's in a square kilometer is 1.6 million square kilometers, which is 2.3 times bigger than Texas. 2.3 times bigger than Texas. Today, US election is going on. And for our Gujarati friends, US is also very important. Okay? US में, in fact, when I was, हमारे काफी गुजराती दोस्त हैं US में, जब मैं US में रहता था, तो वहाँ पर आपको आज आप तो हॉलिडे इन तक छोटे-छोटे मोटेल्स, पेट्रोल पंप्स, and Patel brothers को तो शायद आपने नाम सुना ही होगा. They have it's like they have a huge chain of grocery stores, Indian grocery stores throughout North America. And from छोटे-छोटे motels for petrol pumps जो वहाँ gas station बोलते हैं, 7-Eleven जो एक छोटा shop होता है, and सब जगह आपको हमारे पटेल भाई दिख जाएंगे. Mostly पटेल भाई हैं, बाकी भी लोग हैं, but गुजरात के लोग आपको सब जगह दिखाई पड़ जाएंगे. तो so here 2.3 times bigger than Texas. चूंकि आज US election हो रहा है तो इसलिए मैंने उसके आपको just results will come maybe in few hours from now. Right now, last time I checked, Biden was leading a little bit. We'll see how it goes. So 2.5 times bigger than France, 725 times bigger than largest landfill, which is the Apex Regional Landfill, which is in Nevada near Las Vegas. So, and more than 2,000 times bigger than New York City. So if you take Greater Delhi, if you just take the entire Delhi area, so Delhi, New Delhi, Delhi, then we have South Delhi, East Delhi, all those areas together, that area is also close to New York City. So almost same, so 2,000 times like Delhi. That much big of garbage patch, that much big of just plastics. Can you imagine that? That much plastic is there. And but why? So plastic is there, so what? See, somebody may say that, so what? Here is the answer why it is a problem. They don't degrade. 500 years, 450 years, 450 years, 500 years, another 500, 400, 200, 30, 20. So they don't degrade. They stay in the environment for long time. They break down into smaller pieces, and then when they break down into smaller pieces, either they create these type of problem, entanglement of, you can see the entanglement of this turtle. And then turtle will eventually die if somebody comes and clean it up. And while this diver is going down, he can see just floating plastic all around him. Now what happens is there's a small fish, when this plastic pieces gets broken down and it becomes tiny plastic pieces, this small fish thinks that's a food. And they try to eat it, and it goes into their stomach. The stomach feels full, but doesn't get digestion done. So there is no nutrition coming from those plastics, and eventually they end up losing their lives. And that's started impacting the aquatic environment. So as you can see over here, this 6-pack ring, this is a ring which is used to, say, carry a coffee, 6 glasses of coffee or 6 glasses of cold drinks. So, but it is there in the ocean, and then this fish and turtle is just trying to eat it because they think it's a kind of food. So that creates a lot of problem. And these kind of problem in the land where plastic gets in your deer, bear is there, is stuck, this fox is stuck, and then deer again is stuck into the plastic jar. So research have been done recently where they have found that entanglement is happening to many species. The entanglement that you saw of that turtle on the left hand side, couple of just 2 slides ago, the fish, we are seeing entanglement in the fish, in the invertebrate, in whales, in birds, in our penguins, in turtles, again, different types of like gulls, seagulls, and all that. So different, and these bigger the rectangle, more the species they have been found which was affected by entanglement. Entanglement means physical, like bahar se, or that just got entangled and then their movement got restricted. But the another big problem is of ingestion. It's your ingestion getting into their into their inside their body. So that is also a problem. If it gets into their body, that's an issue. So then it gets into the flesh, then it gets the chemical may get into the bloodstream and other stuff as well. So that will affect their health in a very bad way. And these are, if you remember from the food chain, one species is dependent on the other species. So gradually you will start seeing a lot of impact, and finally it will impact the humans as well. So bioaccumulation, that is called bioaccumulation, where the smaller species to the bigger species to the bigger species and finally to the human. In California and Indonesia, recently they did some research. We found that 1/4 of the fish had contaminated plastic. So out of 4 fish, 1 fish had contaminated plastic into their body. So that's a big problem. Not only in the fish, it is also there in the water bottle. This study which was found, which was also a Bisleri bottle right there, lowest and highest number of plastic particles found per liter of bottled water. So find microplastics in 93% of the bottled water. In fact, if you are in Europe or in many places in America or in Canada or in even New Zealand, Australia, it's actually sometimes it's actually better to drink from the tap water rather than bottled water, because tap water is highly regulated. They have to monitor the tap water quality in a very close way, and most of the treatment plant system and the way water supply system works effectively over there. In India, the problem is our water supply system has a lot of leakages and all that. That's why we need to have this type of those Kent, AquaGuard and all that in our houses. Otherwise, if our water supply system is good, if the water treatment plant is working okay, we don't need these plastic bottles. And these plastic bottles actually creates a lot of plastic waste into the world. So Bisleri bottle, again, they found 0 to 5,230 pieces. That is per liter of bottled water. So as you can see, a lot of others are there. Nestle, Bisleri, Danone, PepsiCo, Aquafina. That would be probably Aquafina. Yeah, Aqua, Ipura, Minalba, Dasani, which is a Coca-Cola, Evian. And Coca-Cola has a Kinley too. Kinley is not shown here. So, and on average, they found 325 average number of plastic particles for every liter of water sold. So, pani to peena hi padega. Like even we need to drink water. And many times we think that drinking from that Bisleri bottle or Aquafina bottle is much safer. But they may have plastics. So, choices, should we have bacteria because of like open defecation and other things, and our bacterial count in our supply water, or should we take these plastic pieces? Answer is we should not take either. So we have to manage the plastic waste properly. If we can manage the plastic waste properly, we will not have these kind of issues showing up. And you can see these clogging of the drain. This is in Dhaka, where this is in mosquitoes, breeding of mosquitoes in Tamil Nadu. You can find these pictures anywhere in India. You go around in there with your phone and you will find. Now, there are several toxic compounds where bisphenol, phthalates, POP, persistent organic pollutants, dioxins, noliphenol, PAH, PCBs, and all that. And they are used for certain application, but they do have a lot of negative impact. So that's why we don't want, if we ingest plastic, if you're getting plastic into our body, that will that can create a lot of effect in terms of estrogenic effect, your like a hormonal effect, neurological reproductive damage, carcinogens, developmental and reproductive toxicity. So thyroid hormone, DNA, those can work, can compromise the DNA stuff. So a lot of things are there, and these are the different plastic types for where these kind of chemicals are present. So that's, and they will have, if in fact, affect several parts of the body. So that's the reason why we need to be careful. And from an environmental point of view, plastic industry also has a huge carbon footprint. So it's in 2019, last year, the amount of plastic that is produced in the world, that's the global plastic produced in the world, is your close to 0.9 gigaton of CO2 equivalent. So it is close to 189 coal plants, which is one coal plant of 500 megawatt. So 190, close to 190 coal-based thermal power plant of 500 megawatts each. The amount of emissions coming out of those plants was equal to the amount of emissions came from plastic industry. So that's what it means. And that is going to actually go up by up to 295 and then 615, 2.8 gigaton by 2050. So improper management of plastic waste is creating a lot of cost of marine litter. $8 billion is getting cost, and that includes 622 million annual loss in tourism, close to 82 million the European Union fishing fleet annual losses, all those fishing fleet which gets in there. So a lot of money is involved. So if we can manage this plastic properly, we can save a lot of money from getting wasted. So 4.8 to 12.7 million tons of plastic waste. That is what is like in terms of mismanaged plastic waste coming out. And that is going to increase to around, initially it was 4.8. By 2010, it was 32 million tons. By 2025, it will be 100 to 250 million tons of mismanaged plastic. Mismanagement, which is just going into the environment. Now we talked about the issue of plastic. We talked about the health issues. We talked about the environmental issues. We talked about how it gets into the environment. Now we'll talk about how to manage the plastic, how to manage this plastic waste, so there are different ways you can do it. Mechanical recycling, you can do feedstock recycling, energy recovery, and then if nothing can be done, you put it in an engineered landfill. So mechanical recycling could be palletizing, extrusion, injection molding, drawing, threading, and all that. Feedstock, pyrolysis, gasification, we'll talk about each one of them. Incineration, co-incineration, then finally your landfilling. So for mechanical recycling, one of the first things you need to do is the segregation. Segregation is very, very important. So that's why the Government of India Municipal Solid Waste Management Rules 2016 also suggests that we do wet and dry segregation. So that's dry part will have different components which could be segregated further when it goes to the material recycling facility. So here, this is what the material recycling facility is, which is known as MRF, not the MRF Pace Foundation. It's the material recycling facility for waste. And you do have a material recycling facility in Ahmedabad. If you are in Ahmedabad, you can try to go and try to see it. So here, haulers dump materials onto the tipping floor, plastic bag and nonsense. So put it in this conveyor belt, and they are trying to separate out. A screen then separates cardboard using, so they will have separation of cardboard and other stuff. So cardboard, the big pieces will go in here. Usually cardboard is bigger pieces. The smaller container will get dumped into this another conveyor where the other persons are there. They try to remove certain items. Then after removing those certain items, the paper is collected separately over there. And then you, whatever is in, you have another screen here, whatever passes through, which will be your some of those containers and other stuff. So you put a magnet will take all the ferrous. Then non-ferrous will be left. Then you use this AD current separator. So aluminum will get separated. Then other things will be left, which will be essentially plastic. So whatever is extra, you can just take it out at this level as well as at this level. So once you have a clear idea of what you are going to recycle, you can work on this material recycling facility setup, which can help in segregating the waste. But it can help in segregating the waste only when we have wet and dry separately collected. If we mix everything together, if your wet waste, if your recycled waste is mixed with your wet waste, it's very difficult to do anything with that particular waste type. So from the previous slide, you got the plastic. So you brought the plastic here, sort for different types of plastic. Then you make the granules, wash the granules, you dry them, extrude these wires. From the wires, you make those small beads. And there's different types of plastic, different beads type, and it is ready to sell back to the market. So when we try to recycle in terms of, there are certain types of plastic which is easy to recycle, some is manageable, and some are very difficult or difficult. So here, the green and your light, this green and your what we call this color, maybe light green color or a shade of green. So those two are like 1, 2, and 4 and 5. These are manageable. So these 1, 2 can be easily recyclable. 4 and 5 can be recycled too. Now, if you look at 1 is 11%, 2 is 14%, so 25%. So 25% can be easily recycled. It's easy to recycle. But how much we are recycling as of today globally? Only 9%. So why? Why not 25% at least? So that we can not let this waste go into the ocean. You saw all those nasty pictures. We don't want that to happen. So that 25% should be recycled. Then this 4 and 5 is additional or not close to 40%, 20% and 19%, so 39%. Another, this 39% is manageable, so they can also be recycled. So together, if you look at 25 plus 39, so you have 65% of the plastic waste which could be recycled. But we are recycling only 9%. Because, again, lack of source segregation, and source segregation. So if you have to get few things out of this lecture, which I want you to remember for the rest of your life, is that without doing proper source segregation, you cannot have an effective waste management system. You need to have proper source segregation, wet and dry, सूखा कचरा, गीला कचरा. आप लोगों ने देखा भी होगा कि उसी तरह से आपके म्युनिसिपैलिटीज के ट्रक आने लगे हैं. अहमदाबाद में तो मैंने खुद ही देखा है, जो म्युनिसिपैलिटी के ट्रक आते हैं, जो सूखा कचरा अलग, गीला कचरा अलग. Along when the system starts, there may be some problem. There might be some issue that कभी-कभी वो कचरा मिक्स हो जाता है, किसी के गलती से मिक्स हो जाता है, कोई knowingly उसको मिक्स कर देता है. But we have to work on that system. माने एक दो को ऐसा इंसिडेंट होने पे हम खत्म नहीं कर सकते, because we have to work so that those incidents does not happen, and we have to get this wet and dry separated garbage. So if we can do that part, then you think about here, if we had just the dry plastics coming into this recycling facility, dry paper, plastic, everything together, they can easily take the plastic out. अगर इसी में अगर कोई कोक का बॉटल गिर जाए, जिसमें थोड़ा कोक अभी भी है, थोड़ा सा कोका कोला अभी भी पड़ा हुआ है, या आपके गुजरात में जो एक बहुत ही फेमस ड्रिंक है सोसियो, मैंने सूरत में देखा, फिर मैंने यूएस में देखा. यूएस में इंडियन ग्रोसरी स्टोर में सोसियो मिल जाती है. सो यू कैन थिंक अबाउट दैट, इट इज सो फेमस. वहां पर आपको थम्सअप से ज्यादा सोशियो मिलता था. तो एंड जो इवन आप जेठालाल अगर देखते हो तो रोज आफ्टर डिनर दे गो फॉर दैट सोडा. तो सोडा पीने का एक रिवाज होता ही है. सो दैट्स ऑल दोज. So those everything we can easily recycle. So it can be recycled and brought it back into the market. So, but right now we are not doing that. We are just we are even the very difficult I can understand, and which can essentially go to a waste to energy plant rather than dumping into the landfill. They should go to a waste to energy plant for energy recovery. And if you do that energy recovery at around 1000 degrees centigrade and above, air pollution problem is also not there. Air pollution problem comes because of incomplete combustion. You guys are mechanical engineer, you know that incomplete combustion of fuel will create a lot of issue. So same thing, if we can design our waste to energy plant in such a way so that there is incomplete combustion is not there. If you can prevent that, so that PAH, dioxin, furans, and other air pollutants will not be generated. So things can be managed. The problem is when you mix everything together. As I was trying to say that in your plastic, if somebody drops Coke or soda in there, then that plastic has to be clean. Now, cleaning requires water. Water has an environmental footprint. Requires a lot of. You have to set up a place like money and energy is wasted there. So, if we can keep the wet and dry waste separately, that can really help our waste management infrastructure. So there are recycling rate of various containers. Plastic drinks, nearly 74% of the plastic drink bottle is recycled, 70% of consumer glass, 70% of consumer aluminum cans, 70% of our steel cans, and 37% of cartoons. So plastic container does get recycled, and that was in UK. That was the data from UK, not in India. So waste plastic, if you cannot recycle them, I said you can do the fuel. You can make fuel out of that. So you can do pyrolysis, you can produce solid char, then you have liquid oil, you have the syngas, which would be used for energy sources. So that is also possible. You can send it to the waste to energy plant. It has a good calorific value, so it can go to waste to energy plant where it will produce energy. It can be used as an energy source. So there are different advantages and disadvantages of the different process. So it again depends on your local conditions. There is no one size fit all solution in general for waste management, and in particular for plastic waste. It will depend. Like if you don't have, say, if you want to put a very rigorous recycling system in place, but you don't have any market for recyclables there. If you are in, say, if you're in New Zealand, for example, New Zealand, they don't manufacture much. So even if you set up a very good recycling system, and within New Zealand, you have to find a market outside New Zealand. If you have a good product, there will be market outside New Zealand. Nowadays, we are under World Trade Agreement, isn't it? So we cannot really. If it's somebody wants a certain material, we put into the marketplace, e-marketplace, and people can bid from anywhere in the world and can get that product. So that's that can be done, but in locally, if you want to set up something in New Zealand locally, that may not work that much because you don't have enough market. So market has to be there for anything to be profitable. So there are different kind of issues like advantages, disadvantages for different types, which you can always find that. So in India, we are also using plastic waste in road construction. Government makes use of plastic waste in road construction mandatory, that if you are within 50 kilometers periphery of a particular city where the best plastic is generated, you have to use it in the hot mix for concrete bitumen roads. Again, here the problem is if it's not source segregated, if it's not clean, then you cannot use that waste plastic into the road. If it's all mixed up with the street sweeping, with a lot of other stuff, which lowers its plastics characteristics, then nobody will take that plastic. So it has to be used in road, but it has to be of a good quality. Although it's a waste material, but it has to be of a good quality. Otherwise, contractors will not take it because it will affect their road performance. And if something like that happens, their bill may be stuck. So they don't take much interest unless they get a very clean plastic coming their way. So in terms of management, globally, 6,300 million metric tons, 9% recycling, you saw that, 12% incineration. In India, we have close to 26,000 metric ton per day. And in India, we are saying that nearly 60% is informally recycled. We don't have the data, but based on the guesstimate, the CPCB report suggests that it is around 60%, and 40% is going to the dump site mostly, and some to engineered landfill. Canada banned single-use plastic as early as 2020, like they were planning to ban it 2021. European Parliament also votes to ban single-use plastic. So that's another, single-use plastic is something which we need to which we need to control. So 2 more US states approved bans on single-use plastic bags. So that's also need to be looked into. India, there was a thought this is last year actually, this is 2019, that India had a thought of banning single-use plastic products from October 2nd, but then there is no alternative. So if there is no alternative, there is no point of banning something unless providing a proper alternative for that. So that's the reason I think our Prime Minister, there was thought, in fact, Prime Minister himself mentioned that in some of the, some of his talk in his speeches and all, But later on, after looking at all the different scenario, the government decided not to go ahead with that. And I agree with that government's decision because see, you ban तो दहेज भी बैंड है कि नहीं? तो बैन तो कुछ भी कर दीजिए, लेकिन जब तक उसका आप प्रॉपर इसका रिप्लेसमेंट नहीं देते तो बैन का कोई मतलब नहीं है. दैट बिकम्स मोर ऑफ ए करप्शन इशू. लाइक पीपल विल डू इट, चोरी छुपे लोग करेंगे, फिर वो पैसा खिलाना पड़ेगा, पुलिस को खिलाओ, इधर खिलाओ, उधर खिलाओ. उससे अच्छा है कि लेट्स वर्क ऑन गेटिंग एन अल्टरनेटिव and then try to curb the use of single-use plastic. So it's then what government finally decided to do, that no immediate blanket ban on plastic, mass awareness to curb usage, which was there were a lot of mass awareness before COVID. After the COVID has hit, plastic, many people are using lots and lots of plastic. And now in Indian context, we'll get actually much higher plastic now than what it was, in fact, just a couple of years back. So in terms of plastic in Indian context, we have several rules which was announced. And in these rules, as you can see, the plastic waste rule first came in 2011. And then it was revised in 2016. So there are different solid waste management rules as well. So plastic being part of municipal solid waste, it kind of does come under 2000 MSW rules or 2016 waste management rules, SSWM rules. So it will come under that as well. So that needs to be looked into. So that was kind of a little bit on different types of scenario, different types of treatment scenario that we can look at. Now I'll give you some examples from some projects that we have been working on related to plastic. This is Plastic Sea to Source project, which is funded by National Geographic Society, the Net Geo. You watch that Net Geo TV, it's the same National Geographic. So they have funded this project to us, and they want to look at how to prevent plastic from reaching the ocean. So that's what the overall goal. So based on that, we have identified several sites along the river Ganges. So this was actually, this project is focused on river Ganges for trying to prevent plastic getting into the river. So for that scenario, we have taken 10 sites along the river Ganges. Out of that 10, 3 happens to be in Bangladesh and 5 rest in India. So we didn't do for Bangladesh. For Bangladesh, there was another team doing from Bangladesh itself. But for the Indian sites, we have done a detailed site assessment. We have done a lot of survey. We have done a photographic survey. Then we have done a lot of interviews with the local officials there. And then we have done collection of samples and looking at how the waste is being managed in that area. How much plastic is there, what kind of plastic is there, and how this plastic is being managed, and what can be done so that we can manage those plastic waste more effectively and not let this plastic getting into the river Ganges. So that's the whole big picture goal of this particular project. So this is, as you can see, me, myself, along with my like a US colleague, and our students, students who are working on this project. So this is we were looking. This is we were called the land team. We had a water team as well. This land team was looking at the waste. Water team was looking at how much microplastics showing up in the water. In that picture on here, this picture you see on the background is the river Ganges in Rishikesh. That's where the picture has been taken. So we looked at the junk shop survey, what is happening to those informal recyclers, where the waste is being taken away, what is being done. And then we also did what is known as littering. We try to find out how much littering we see in a particular city, and we try to come up with that littered index. So as you can see over here, these are different patches. Those patches are where this transects where this littering was measured. And how it was measured was essentially we had a 1 feet by 1 feet, 3 feet of this square, where we were using this a square on a particular place, and then we will measure how much littered pieces is there and what is there in those pieces. And that was tracked into an app that was developed. So we put that into an app, and then we come up with those data. And then we used to do it at every site. You can see this. We would walk with this and do it for at least 100 meters. So within like we'll do one, then walk for another some time and walk do another, then another, and then another, and we'll keep on doing that. So that was the plan, and then this is what we found. We found that in total items was 56,881 items just for the limited area that we have done, and 12,782 plastic food wrappers, 9,410 tobacco sachet, this much of sheet-like plastic fragment, 5,000 papers, and 3,620 cigarettes. Cigarettes we found more on the Bangladesh side, less on the Indian side. We found more tobacco sachets on Indian side, less on the Bangladesh side. So which kind of tells you some idea about that. We know the tobacco sachets, those Manikchand, in fact, that is another very famous thing. Like many people coming to India from US will actually buy lots of Manikchand pouches and take with them to US for their friends and family. Sometimes you can even sell them. अगर दो सूटकेस में एक सूटकेस किसी तरह से आप मानिकचंद ले जाओ तो शायद आपका भाड़ा ही निकल आए. ओके, अगर आप $2, $1, $1.50 पर सैशे बेचोगे तो भी it gives you a good amount of money. So so as you can see, this is your this is called average litter density per square meter. So Rishikesh was close to 8, a lot of littering there. Chandpur in Bangladesh was the highest. The lowest was also in Bangladesh, 3.4, which was in Rajbari. So these three was in Bangladesh. But in India, as you can see, Varanasi was 5.3, Kannauj 4.8, Harsil 4.6, which is Harsil is kind of a little bit of pristine area, but it's still 4.6 liter per square meter. Rishikesh, Anupsahar, these areas we saw pretty high number. So again, this all depends on how you choose these maps and other stuff too. So there might be some local influence there. So we tried to choose this, try to get a representative field for that particular town. So this is the same thing put into a this data put into a like a box. So food wrapper was number 1, then tobacco sachets, then sheet like plastics, and then paper, and then cigarettes and other stuff. So individually also we did this. What kind of different things we see? These are all tracked into that app. So now you might be thinking that what is the importance of doing all that? See, we can present this data to the local officials and tell them that what is the problem, because what is happening is we are shooting in the dark in terms of waste management. We just try, we have to do something, we do it, but we never really do the homework properly. For example, if you're looking at plastic waste, okay, how much plastic waste we generally really produce? Say how much plastic waste is really produced in Anand or in Ahmedabad. You will not have that data because we never measured that data. So we have to know that data. So if you want to design something, when as a mechanical engineer or a civil engineer or any engineer, when we design, we need to know, for mechanical civil, we need to know the load, isn't it? We need to know the load on the beams and columns. Then only we can design that beam and column. So here for say waste, we don't know how much load is coming. So we need to know how much load is coming, plus minus 10%, plus minus 15%, but has to have an idea. So that is the how much. And the second thing is what is there. What are the materials there in that waste stream? So that, and what percentage? So that I can find out, say if I want to set up a plant for plastic processing, how much plastic will I get every day? That's very important. So that's so all those, so when doing these exercise will gives us like what is the, how much plastic is being mismanaged, how much plastic is just getting into the just staying around, and then what it will end up into the river, and finally to the ocean. So that in that way we can have a like we can present to the municipal authorities and tell them that you need to work on it. You need to work on these items. So if you can do something along with this item, and then we can suggest them some technological solution in terms of reusing those like waste as well. Similar picture in Patna. Drains getting into the river. As you can see, the drains getting into the river. That's mostly Ganges, some other rivers as well. So as you can hear, also drain getting into the stream. Then the stream will take it. This is like a very big nala, and that stream will take it to the bigger nala, and then finally it will go to the like a river or to the ocean, and from the river it will go finally to the ocean. So these are the things which we need to focus on. Drain. You can see here, waste everywhere. A lot of waste, which is creating a lot of an issue. Then drains falling into river and all that. So you can see those stuff happening. Then one thing which we found was presence of plastic in cattle excreta. So in gobar we found plastic pieces. That's actually scary even for a vegetarian. Milk तो सब लेते हैं हम तो vegan नहीं है, vegan लोग milk भी नहीं लेते. So but we do take milk. Now if in the stomach is the plastic which the cows are eating, and you can find cows in many of those dump sites, and if they are eating those plastic and then it is showing up in their poop, in the gobar, that means part of it could be absorbed into the body too. And if it's being absorbed in body, then it creates a lot of problem. It will be our milk will have plastic chemicals in there. So that which we don't want that to happen. So that was we are working on the final report of this particular project from National Geographic, which will be submitted soon. It will be up in my like a National Geographic website, and also I'll put a link to my website. So later on you can have a look at it. That report will be out by end of this year. So then we also worked on this particular work on plastic as a key to addressing ocean pollution. And this is a high-level panel for sustainable ocean economy, which is unique initiative by 14 world leaders. As you can see, the world leaders from Canada, Mexico, Jamaica, Ghana, Namibia, Chile, most of the countries which is dependent on ocean for a good part of their for a good part of their research and for their revenue source, for their market. So they need to have the ocean clean. So these countries came together, and then they came up with this high-level panel. And since we have done some work on plastic, somehow I got a call from them to help with this high-level panel, and then do a blue paper on plastic issues. So we did that. This is what we have, leveraging multi-target strategies to address plastic pollution in the context of already stressed ocean. So these were the three lead authors: myself, Jenna Jambak, and Miss Ellie Moss. And we were the lead authors, but then we had the authors from pretty much everywhere, every continent. So we had people from every continent who contributed towards this report. And then we had this is just a picture showing the different countries from where the authors came from. So in terms of some facts, 5 to 13 million metric tons of plastic go into the ocean each year, which is as good as you put one dump truck of plastic per minute. You have a dump truck, you are just dumping a truck of plastic waste into the ocean every minute. So that much of plastic is going into each year. 13 billion per year in damage to marine environment. So that much that much damage is happening. 3% of ocean plastic is floating. 97% actually is in the sediments. So 97% of the ocean plastic is in sediments. So we have to deal with that as well. Otherwise, they will get resuspended too. 1.9 million microplastic per square meter on the ocean floor. So a lot of microplastics present in the ocean floor. Now, how to clean it up? So in general, we don't take proactive approach. We always get into reactive approach. Once we create problem, then we try to solve the problem, rather than trying to not work in such a way so that the problem is not created at the first place. So here you see a lot of sources of different types of ocean pollution coming from plastics and other sources as well: oil platforms, industries, industrial recreational stuff, animal, you will get fertilizers and other stuff coming in there, atmospheric decomposition, recreational boating, cruises, aquaculture, disaster debris. So a lot of things you can find gets into the ocean, which based on, we cannot solve problems for each one of those, but at least based on our understanding and our background, we can do some sort of intervention. So it's a municipal sources, agricultural, aquaculture sources, industrial sources, also maritime sources. And these are the different pollutants that is looking at: microplastic less than 5 millimeters in size, macroplastic, other solid waste, residue, nutrients, antibiotic, heavy metals, industrial chemicals, and all that. The ocean was getting affected. The ocean health of the species are getting affected, and people who are dependent on ocean for food is also getting affected. Economy is getting affected there as well. So what needs to be done? You have to improve the wastewater treatment, improve stormwater management, apply green chemistry principle, and then do some coastal zone, build local system for food supply and all that. So those we recommended all these summary interventions. If you are interested, you can download that. You just put blue paper. If you just say blue paper on, you just have to call it like multi-target strategy for addressing plastic pollution. You can just say blue paper plastic pollution, and you can put my name there, and then you will definitely find that on Google. So it has nutrients, has antibiotics, heavy metals, and other stuff. So these are some of the recommendation interventions suggested. And then if you are interested in more there, you can look at these this report over there. Then we also offer a lot of courses. Probably you came to know about me through these courses. That's what I'm guessing. We have several courses on online, which we offer on waste management in general, including a course on plastic waste. Plastic waste course was offered in January to April 2020 also. This is 2019 here, but 2020 also we offered it. And 2021 is also we are going to offer it. So it will be there. And then we have several other courses as well. So this report from the World Bank came a couple of years back in 2018, where they talk about all these different categories. So metal, glass, plastic, paperboard. The plastic is around 12% now of global average, and then food and green. So what I wanted to highlight, I think this is my last slide. So what I wanted to highlight is that, say, individually metal has market, individually glass has market, plastic has market, paper and cardboard has market. Food and green also can be composted or anaerobic digested. The problem comes when everything gets mixed up together. When you get each one of these mixed up, and that's where you have an impact. Pura mix ho gaya, aapka pura khichdi ho gaya. And once it's like this, nobody wants to have glass pieces in the compost. Nobody, well, they buy the compost, will like to have metal pieces there as well. So that creates an issue. So that's the reason why the source segregation. So this is wet and dry. So that sukha kachra and gila kachra. So gila kachra is this part. So that's your gila kachra right there. And your sukha kachra is all these four. All these four is your sukha, like dry waste, which you can collect in one bin, and then that can be separated at the material recycling facility easily. So this is the research group. Some of the project that you saw regarding this plastic is done by some of these students. So most of the work, as you know, you guys are also academic. We, like, students is kind of our backbone. The students do a lot of hard work, and then they help us to look smart in public audience by putting their effort and generating good data. So thank you. As I promised, I said that I'll close at around 11:15, 11:20. So right now it is 11:14 by my watch. So it's so questions are welcome. If you have any question, I'll be more than happy. We can have question, comments, discussion, everything. So I'll stop my sharing and then put it on the normal mode.
Thank you very much, Dubey sir. It was really a wonderful presentation. The session is now open for participants to ask their questions or say queries. Yes, so participants can ask the questions now.
And you can ask in English or Hindi or even मुझे गुजराती थोड़ी आती है. I can understand Gujarati and I can reply in Hindi if you want that.
Sure, sir, sure. Yes, anyone having any kind of questions?
सर सिंगल यूज प्लास्टिक को आपने बोला ना 40% अप्रोक्सीमेट है, तो उससे कम या ज्यादा किया जा सकता है?
हाँ, कम कर सकते हैं अगर हम सिंगल यूज प्रोडक्ट नहीं यूज करेंगे. जैसे मान लीजिए आप जो प्लास्टिक कप्स यूज करते हैं, प्लास्टिक की प्लेट्स यूज करते हैं, आप अपने घर में कोई पार्टी कर रहे हैं तो आप प्लास्टिक प्लेट्स मत यूज कीजिए. आप रेगुलर जो चाइना प्लेट होता है या स्टील प्लेट होता है वो यूज कीजिए. तो यूसेज करके ही हम उसको कम कर सकते हैं. सिंगल यूज प्लास्टिक का तो वही मतलब हुआ कि जो आपने एक बार यूज किया फिर फेंक दिया. और स्ट्रॉ है, बहुत बार हम स्ट्रॉ चाहते हैं कि स्ट्रॉ मिले. अब हम नारियल पानी भी पीने जाते हैं तो उसमें हमें स्ट्रॉ चाहिए होता है। तो अगर वो लोग अपना कोई डिफरेंट मटेरियल्स के आजकल स्ट्रॉ भी बनने लगे हैं, आपको इवन बैम्बू के स्ट्रॉ बनने लगे हैं। तो रादर देन यूजिंग प्लास्टिक, अगर हम कोई दूसरा मटेरियल उसमें यूज कर पाए तो वो यूसेज पे ही है। मैंने मार्केट में अगर इस तरह से सिंगल यूज प्लास्टिक को धीरे धीरे फेज आउट करना थोड़ा जरूरी है, स्पेशली दो जो थिंग्स विच कैन बी फेज्ड आउट इजिली, तो ताकि हमारा प्रॉब्लम थोड़ा सा कम हो जाए। तो अगेन इट डिपेंड्स ऑन हाउ वी यूज इट। तो आप अपने बैग लेके मार्केट जाएं तो फिर वो जो आपको बैग में देता है सामान, वो बैग लेने की जरूरत नहीं पड़ेगी, आप अपना थैला लेके जाएं। तो इस तरह से ही उसको कम कर सकते हैं।
थैंक यू सर।
There is a question on the chat box. Is it possible to reinforce composite from plastic with metals? If yes, then where it is applicable nowadays? Composite from plastic. In fact, people have done. People have made plastic bricks where they have. आपने eco brick का भी शायद नाम सुना होगा. Eco brick is kind of very popular these days. Where what they do, they will take a plastic bottle and say if this bottle is of plastic, ये तो copper का है, but just imagine कर लें कि ये plastic का है, तो इसके अंदर जो भी आपके घर का प्लास्टिक का वो रैपर वैपर जो भी आ रहा है वो इसके अंदर भरते जाइए। इसको बीच बीच में आप इसको यू पुटे लाइक एक छोटा सा आप उसको प्रेस भी करते जाइए, इसको पूरा कॉम्पैक्ट बना दीजिए और उसको क्लीन डालिए। जैसे आप बिस्किट का रैपर है तो बिस्किट खत्म करके डालने का है, बिस्किट का वो थोड़ा सा भी उसका डस्ट वस्ट जो है उसको नहीं छोड़ने का उसमें। तो उसमें आप उसको डालने के बाद जब पूरा अच्छे तरीके से वो पैक हो जाता है, इट बिकम्स ए स्ट्रॉन्ग बॉटल that is being used to make like a fence wall and different type of stuff. और अगर वो नहीं कर सकते तो कम से कम प्लास्टिक साफ सुथरा है। सो प्लास्टिक साफ सुथरा है तो रिसाइकलिंग में वो आसानी होगी, प्लास्टिक वेस्ट टू एनर्जी प्लांट में आसानी होगी क्योंकि क्लीन प्लास्टिक है। बट टू आंसर योर क्वेश्चन इन टर्म्स ऑफ reinforced composite from plastic with metals, people are doing that. Yes, it is being done. People are making different products from recycled plastic where the reinforcement of metal is done to give it a strength, and plastic is also being used for making bricks, making like people put a compressed plastic। थोड़ा सा वो मैंने कोचिन में देखा था। अगर आप लोगों में से कुछ लोग जानते होंगे दैट अमृतमयी अम्मा जो वो आपको हक करती है, लाइक द हगिंग सेंट, उनके अगर आप आश्रम में उनके जो कोची में उनका एक हॉस्पिटल है, एंड सो देयर इन दैट प्रेमिसेस दे डू हैव a small plant where they take all this plastic and they melt it a little bit and they compress it, then put a wire mesh on top of it and then put a concrete layer on top and produce concrete like bricks and all that. So now Ronak Patel has sir, if you want to take initiative to manage plastic waste in small cities, there are many people are not having much knowledge. What are the preventive steps? How can I better using cycle for recycling of plastic waste for the same? So as I was trying to mention, Ronak, as I was trying to mention in the lecture, see, number one thing we need to do is to keep this plastic separate. So number one thing which we can do to, if we can keep the plastic waste separate, at least the dry waste separate, so that the plastic could be recovered. Now, once the plastic is recovered, which is relatively cleaner, then we have to separate them into number 1, number 2, number 3, number 4, number 5, number 6, and like that. So as you saw, number 1 and 2 and 4 and 5 you can recycle for most part. So that, and there is market out there. In fact, Reliance is number one buyer of recycled plastic. Reliance जो है वो number one buyer है recycled plastic का. They buy this recycled plastic back, especially the PET ones. And जो आप फिर उसके इस तरह के ये fibers बन जाते हैं. So आपके जो polyesters वगैरह जो है उसके जो fibers हैं वो recycled plastic से फिर से भी बन सकता है. So those things are being done, but the number one is the step that we have to do in any city or town is to keep this plastic waste as clean as possible, not let it mixed with any other waste stream, especially something which will make it dirty. So you have to do that. So that's your preventive steps. And once you have those, you have to clean it up, and then you can put it in your you can, as I showed you in one of the slide, it has to go through a certain process where you make those small beads and then go back to the market and for making new products out of that. And those type of manufacturing is already there. They are not getting enough plastic. They actually the technology is already there out there. Technology already is available. There are few plants already working, but since the collection, especially getting the clean plastic, is not happening. That's the reason why we see a lot of them getting into the rivers and ocean. Preeti, is there any material which can be added to molten plastic for making leakage-proof surface coating in civil construction? So, molten, if you want to mold the plastic, you have to heat it up. That's what it is being used for. See, if you and one thing you have to be careful that when you melt this plastic, you have to do it in a controlled environment, because it will release some of those gaseous emissions, and you don't want to inhale those gaseous emissions. But if you, in terms of construction, I showed you an example where the roads are being made from this plastic. So especially from those plastic bags and other stuff, they are making these roads. But again, those plastic has to be cleaner. If you have too much dirt and other stuff, your road construction the quality will get compromised. So then you can melt it by heating it up. So you have to, if you want to add any material, I could not really for melting anything, you have to heat it up. Once you heat it up, it will melt. You can add other material to make different types of product. Like you can make tiles. Tiles are being made from plastic. If you go on YouTube and just put tiles from plastic, you will get some example where tiles are made, which last for a longer period of time. Then road construction, it is being used as well. So those are the places where and there are other applications too where things are being done in terms of civil construction. Any other question?
Yes, any other question from the participant side?
Hello.
Yes.
Sir, how gasifier is used to generate energy from plastics? So
it is the same that gasification. You have seen any gasification plants or no?
Sir, now I am working on a bubbling fluid ice bed gasifier in my last year project, but it is used in it is used crop and bagasse and that all things. But for plastic, which we can use plasma pyrolysis, or there is any other gasification process?
Plasma pyrolysis can be done for plastic. That's correct. If you do plasma pyrolysis is a bit costly, but that can be done. In fact, we have done in our lab scale here, we have done some plastic pyrolysis as well, where we worked at around 200 to 400 degrees centigrade, and then we made those plastic oil, which is the oil from plastic, and we also produced what is known as plastochar. So when you do any pyrolysis, you produce char. If you do biogas, it's a biochar. So this is a plastochar. So you can do plasma, you can do normal like a pyrolysis chamber as well, and it depends on what product you want, what you want to do with that plastic. If you want to produce syngas, then of course you have to work at a different temperature. If you want to produce the oil, you will work at a different temperature. So depending on the type, you can do even for that where you are using bagasse. Have you tried using plastic there?
No, sir. Only agricultural waste.
Okay, but I think your plastic should work there as well. You may have to work with that treatment condition a little bit, but plastic should be able to work there as well.
Thank you, sir.
Yes, any other participant? Anyone having any other questions? Okay, then on behalf of Mechanical Engineering Department, ADIT, I would like to thank Dr. Brajesh Dubey sir first for accepting our invitation and then delivering such a wonderful talk on plastic waste management. Sir, you have kept the presentation really engaging, and along with that, lot of fun was there along with the information. Nice to listen that you are having some Gujarat connection as well. So we would also like to invite you, sir, to our institute whenever, say, next time you come to the Gujarat. Interacting with you in person, interacting with you in person will be our great pleasure. So thank you very much, sir. The presentation right from beginning, the way you have started that plastic is not the issue, the waste is the issue. The technologies that you have presented from say mechanical recycling to the different feedstock treatment, the pyrolysis and gasification. The question answers were also you have explained in detail as well to our participants. So thank you very much, sir. We would also like to invite you in some other sessions as well. I personally listened some of your lectures on e-waste management on say NPTEL platform. So that were also really wonderful, sir. So thank you very much, sir, for accepting our invitation and delivering such a wonderful talk.
Thank you. Thank you.
Thank you very much, sir.
Thank you. Okay.
Yeah. Okay, sir. See you.